5G new radio frame
Yes,
structure.
sir.
Okay, this is very important topic, and I would like, or rather, I will seek your attention. Very important. If you understand this, then a lot of things you can understand about 5G. So we will talk about frame structure concept in 5G. Then we talk about frame structure for all the numerology, and this will be very interactive session so that all of you can participate. Then we'll talk about numerologies 3 and 4 and their frame structure. And then visually we'll see how it looks. And then we'll also talk about concept of resource grid. What is the resource grid related to frame structure? And finally, we'll talk about scheduling, slot-based scheduling and mini slot-based scheduling. And perhaps uh, uh, the rest of the two small topics which will be remaining we'll take next time, maybe tomorrow or day after. Okay, so let us first understand the frame structure in 5G. Basically, when we say frame structure, we are talking in time domain. So there is a concept of a frame. So in 4G and 5G, the size of a frame in time domain is same. If somebody knows 4G frame size, please write in the chat box. I think recording is started, so don't worry. Slack. Right. So can somebody tell me that what is the frame structure in 4G so that we also talk about 5G? Please use chat box in case you want to answer this question. Anyone? So it is 10 milliseconds. 10 milliseconds. I think recording is started. Somebody is writing. It's already started. So it is 10 milliseconds. In this 10 milliseconds, it is divided into subframe. So how many? So suppose you have a 10 millisecond.
One millisecond.
Yes, you are right. So you divide into subframes, and every subframe will be of 1 millisecond. And then with every 1 millisecond frame, you divide into slots. You divide into slots. So how many slots?
40.
Number of slots will depend upon numerology used. So here, the slot side is numerology based. For example, if you have numerology 0, that means your slot is also 1 millisecond. If you have numerology 1, then your slot size is half millisecond. If you have numerology 2, then 1 by 4 millisecond, and so on. You can go up to numerology 4, to be 1 by 16th of a millisecond. And then what is symbol? Within a slot, how many symbols can be accommodated? So generally it is 14 symbols.
14 symbols.
And in some case, there will be 12 symbols also. Okay. So let us understand pictorially here. So as I explained, that frame duration is 10 milliseconds. So you have this much of a frame duration. And this gets divided into subframe of 1 like this, 1 millisecond. So frame 0, 1, 2, 3 up to 9, 10 subframe. So you have a 1 millisecond subframe. May I request you to kindly mute your mic, please? Atul, can you mute? Yes. Thank you. Thank you. Okay. So now please understand how many number of slots in a subframe. How many number of slots? So number of slots will be 2 to the power mu, depending upon the numerology. So just tell me, if it is numerology 0, then 2 to the power mu is how much? What is the slot size? Can somebody tell? How many slots? Is 1. If it is 1, then number of slot is 2, then 4, then 8, then 16. So 16 number of slots. So you have more number of slots when you go higher in the number. So this is defined. Then how many symbols? So every numerology, right? In every slot, you can have 14 number of symbols. But in some case, you will have 12 number of symbols, where we use extended cyclic prefix, particularly in numerology 2, that is 60 kilohertz per spacing. We use extended cyclic prefix and we are able to accommodate only 12 symbols. Okay, so number of symbols will be 2 to the power mu. I mean, the time if you want to calculate will be like this. Okay, so this concept is clear. Any doubt here so that I try to clear it?
You are saying that number of slot equals to numerology. So as you earlier told that we are using numerology 0 to 3, 0, 1 to 3.
0 to
right?
4.
4 is for reserved for the signaling.
Yes.
So 2 raised to the power 3 means the question is like how the maximum 14 slots can be defined.
So please understand. First you have frame, then you have subframe, then you have slot, and then you have number of symbols in a slot. This is the hierarchy. So let us take one example. Suppose my numerology is 0. So my frame size is 10 milliseconds. My subframe size is 1 millisecond. Number of symbols is again 1 because numerology is 0. And in one symbol, I'll have slot, I have 14 symbols. This is slot. And this is symbol. So this is, suppose you have numerology 1. Frame size will be same. Subframe size will be same. But since numerology 1, number of slot 2 to the power mu means 2. So that means 14 symbol in one slot, 14 symbol in another slot. The total symbol I can have 28. Is this okay? Is this answers your question?
Yes.
And we'll do a lot of exercise on this. Okay. So visually, just to understand, here what is shown is a 10 millisecond subframe. That means I have 10 millisecond of frame, which has got subframe 0, 1 up to 9. Within this 1 millisecond subframe, right, will be only one slot because of numerology 0. And within that one slot, I have 14 symbols. 0, 1, these are symbols. 14 symbols in one slot. If I use 30 kilohertz, then my slot size is half a millisecond. So that means I have two slots, slot 1, slot 2, within the same 1 millisecond. And within this, I have a 14 symbol. So I have 14 plus 14, 28. Suppose if I have 60 kilohertz, then my slot size become 1/4 of a millisecond. That means in 1 millisecond, I have symbol slot 1, slot 2, slot 3, and slot 4. So within slot 1, I have a 14 symbol, 14 symbol, 14 symbol. So I have 14 into 4 number of symbols. If I have 120 kilohertz, then again it is size is 1/8 milliseconds. So I can have this much slot, 8 number of slots. Is this clear in this picture? Any doubt here? Okay, good. Now this is for you. So now that I have tried to explain, now it's your time to answer. So suppose I have 15 kilohertz subcarrier spacing. So how many slots will be there in one subframe? How many slots will be there in one subframe? Either in chat box or you can speak. I have one answer, two answers, two correct answers.
One, sir.
Yes, very right. So people have tried answering this. Okay. Okay. Then very right, very right. Perfect, perfect. Now, how many symbols per subframe? How many symbols per subframe? Because you have only one slot in a subframe. So how many symbols?
14.
14. Right answer. And how many slot per frame? How many slot per frame? So in one
114.
subframe, you have one slot. So with 10 millisecond frame, how many slots would be possible?
10. 10.
Very right, 10 slots. Then how many symbols within the frame? You have 14 symbol in one subframe. Now you have a 10 subframe. The total how many symbols?
140.
140.
Keep writing in the chat box. Yes, 140. Very nice, very nice. Now do this math for 30 kilohertz. Then how many slot I have in 30 kilohertz in 1 millisecond subframe? The
Two, sir.
slot duration here was 1 millisecond. Here is a half millisecond. So I can accommodate two number of slots, right? So within that 1 millisecond, then how many symbols I can have? I have
28.
two slots. One slot can have 14. So 14 into 2, that means I have 28. Now, how many slots per frame? In one subframe, I have 2. In 10 subframe, how much I can have? Yes, your
22.
answers are right. You can have
80.
20. And how many symbols you can have in a frame? 10 millisecond,
280.
then
280. Just
280.
double one each above side on the one.
Very right. Now you have understood that you just double it everything. I'm doing that. So you have understood I'm doing that. So what will be 28 into 2? 56. Just tell me here what will be the figure. Will it be 112 and 224? Am I right? 40, 30, 160. Am I right or I'm wrong? Just tell me this figure. Please calculate and tell me.
Answer.
Please speak out. How much it will come? 560. Then 1120. 3240. Anybody is having doubt? I don't think people should have any doubt here. Okay, so now question comes for you. For numerology 2, what will be the slot duration? Please answer. A, B, C, D. For numerology 2, what is the slot duration? Please answer this question. For numerology 2, what will be
0.5.
the
C.
slot duration? 0, 1, 2. So in 0, you have 1 millisecond slot. In 1, you have half millisecond. In 2, you have 1 by 4 milliseconds. So which one is correct?
C.
0.25 may not be the answer. Somebody is writing 0.25. Yes. 1 by 4 is 0.25. So you are correct. You are correct. Yes. D is the answer. Great. Now, how many number of symbol per subframe? In 1 millisecond, numerology is 3. How many symbols? In numerology 0, we have one slot. That means 14 symbols. In numerology 1, numerology 2, numerology 3. 3 is asking. Here you'll have 2 slot, then 4 slot, then 8 slot. So what is the answer?
112, sir.
0, 1,
112.
Okay, great. Great. Okay, so Now again, question for you. Coming. So this has to be filled up by all of you. So this is a 15 kilohertz sub-carrier spacing. So in 15, you answer this. What is the frame duration? Somebody can speak. What is the frame duration?
10 milliseconds, sir. 10
10
milliseconds.
millis. And subframe,
1 millisecond.
slot per subframe.
And
How many slots?
1.
One, sir.
One. What will be slot duration?
1 millisecond.
1 millisecond. How many symbol per slot?
14.
14.
How many symbol per subframe?
Frame.
And how
14.
many symbol per frame?
140.
Very right. Now let's, you guys are right. Now let's calculate for 30 kilohertz, that is numerology 1. So the frame duration remains same, subframe duration remains same. 10 millisecond, 1 millisecond. How many slots per subframe?
Sir.
How many slots?
2.
1 and 2. Then what is the slot duration then?
1 by 2.
millis.
Yeah, 0.5.
0.5 millisecond. Then how many symbols per slot?
14.
14.
So how many symbols per subframe?
28.
28. And per frame?
280.
Understood, everyone? Okay, so now, yes, your answers are correct. Now do it for 60 kilohertz. Your frame is 10 millisecond. Your subframe is 1 millisecond. How many slots you see? 1,
4.
2,
4.
3, 4. 4 slots. And what is the slot duration? 1 by 4 millisecond means 0.25
0.25.
millisecond. How many symbols per
14.
slot?
14.
It can be 14, it can also be 12 because
12.
of the 60 kilohertz, right? So calculation you should do for 14. So how many symbols per subframe? 14 into 4 because you have 4 slots. How much?
64. 64.
Okay. And per frame will be 560. Great. Okay. Now let's do it for 120 kilohertz. So frame subframe same. So how many slots now?
8.
1, 2, 3, 4, 5, 6, 7, 8 slots, right? So slot duration will become 1 by 8 millisecond. That means 0.125 millisecond. How many symbol per slot? Always 14. So how many
14.
symbol per subframe? 14, 8. How much?
112.
Of
112.
112. And per frame will be 1120. The last is for 240 kilohertz. So here how many slots? 1, 2, 3, 4, 5. How many? 16, right?
16.
Because of the time duration of the slot has become 116. Slot duration has become now 1 by 16 of millisecond. That means 625 nanoseconds. Should I say 625 nanoseconds?
625 nanosecond.
Okay. And then what is the symbol per slot? It will be 14. And per subframe will be 16 into 14. How much?
288.
288. And total in a frame will be 388. Very nice. I hope everyone has understood the frame structure. If you read the standard document, it takes very long time to understand. Okay, so now in an Excel sheet, I just drew the entire picture. So you can understand for numerology 0, you have 1 slot. For numerology 1, you have 2 slots within the same 1 millisecond frame, 4, 8, and 16. So if you go higher in numerology, your sub-carrier space is increasing, 15, 30, 40. Slot duration is decreasing. This is ulta. half going on. So number of slot would be doubling 1, 2, 4, 8, 16. And similarly, number of symbols in a millisecond will also increase. So this is the concept. Now let us see visually how what we understood. So just see visually, same thing in a visual manner. That suppose you have a frame of 10 milliseconds, and then you have one subframe of 1 millisecond. So 15 kilohertz, you have one slot. In 30 kilohertz, you have two slots. In 60 kilohertz, you have four slots. Same concept in a different visualization. Here the concept is if you are increasing in numerology from 15 to 30, 30 to 60, 60 to 120, 120 to 40, your time is becoming half from 1 millisecond to 0.5 millisecond to 0.25 and so on. But for frequency domain, you are doubling, right? Your RB bandwidth is doubling, 15 kilohertz, 30. So overall, if you see, time you are reducing, right? But within the smaller time, we'll be able to pack more data. Just understand here that here, within 1 millisecond, I'm able to accommodate so many number of symbols. And per symbol, you know that if I use QAM4, I can transmit 2 bit per symbol. So within this slot, I have 14 symbols. So that many number of bit I can transmit if I'm using QAM4. If I'm using QAM64, then higher number of bits can be transmitted. So within a smaller time, I'm able to transmit more data bit, but my frequency domain frequency has become double. That's why I'm able to support more number of data there. And also, please understand here concept of latency. If you want a less latency, then what you should use? Let me here itself I'll tell you. Normally, the allocation of resources to UV is done during every slot time. Every slot time. So suppose I'm using 15 kilohertz sub-carrier spacing, which slot duration is 1 millisecond. Okay. So what will happen? Suppose UV has some data to transmit. UV has some data to transmit. So it has to wait for a new slot to come in a time domain. 1 millisecond has to pass, and then UV is given resources. Right? So here latency of 1 millisecond is all because of scheduling. That data can be scheduled only every millisecond, not before that. So you cannot have a latency of 1 millisecond because there are other factors also coverage. Using the numerology 0. But if you use numerology 2, your scheduling can happen every 0.5 millisecond. Every 0.5 millisecond, I can allocate resources. So if some data is coming, the data can be transmitted just after 0.5 milliseconds. If I use 60 kilohertz, it is 0.25. That means if I am going higher in numerology, my latency will also improve. My latency will also improve. Please understand this concept. If I go in higher in latency, that means for a latency sensitive application, I need two things. One is that I should have a small coverage so that latency because of the propagation is less. I need to use higher numerology because in higher numerology, my slot duration is less. So I'll have a less waiting time. So my latency will improve. I have to use higher frequency because I'm trying to use higher numerology and I'm trying to have a lesser coverage. So it is a win-win situation that if I have a higher frequency, I'll create a small cell, I'll be using a higher numerology. So any question here? Any question? So if you have understood, please write yes in the chat box that yes, I have understood this concept. Please write yes in the chat box if it is okay. Okay. Now let's visualize it. Same thing in a visual. So with 15 kilohertz, my frequency size here x-axis is time. So just see 14 symbols. I have 15. If I have 30 kilohertz, I'm able to pack more number of symbols in half domain, and so on. See that your frequency domain is increasing, your time domain is decreasing as you go higher in numerology. Okay, now the concept of resource grid and concept of scheduling. Next two portion I'll be covering, and then we'll finish it by 5:30. So first of all, let us understand what is resource grid. So resource grid, just see the picture on the left side. On this axis, this is time domain. This is time. So a resource grid duration is one subframe. That means 1 millisecond. Subframe is always 1 millisecond. And on this axis, you have frequency, subcarrier. So one subframe spread over the entire channel bandwidth is called resource grid. It's called resource grid. Okay? So that means one subframe in time domain, full carrier bandwidth is called resource grid. Called resource grid. So for uplink, you'll have a separate resource grid. For downlink, you'll have a separate resource grid. And then if you have multiple antenna ports, if you have multiple layer of transmission, so for each layer of transmission, you'll have a separate resource grid. For each numerology, you'll have a separate resource grid. That means for every combination of antenna port, subcarrier spacing, and transmission direction, we'll have a separate resource grid. I'll stop here for any question before I explain it further. Any question you may have as of now? It looks like everyone is tired today. Okay, fine. So let's understand concept of resource element. Same diagram I have shifted this way. So here we have 1 millisecond, and here we have subcarriers and total number of carrier bandwidth, whatever number of subcarriers. So my question to all of you that in time domain in one subframe, these boxes in vertical directions are number of symbols. So how many symbols I will have in one grid? Any answer from your side? If I have to ask you that in a one resource grid, how many symbols will be there? So Mr. Patel has said 14.
It will depend on numerology, sir.
Very good, very good, very good, very good answer. So somebody has said 14, but suppose you are using numerology 1, then within 1 millisecond, how many symbols will you have? Please write in the chat box. Suppose you are using numerology 1, then how many symbols will be there in a resource grid? 28, because in 1 millisecond, I have 2 slots, and in 2 slots, I can accommodate 28. If I use numerology 3, then my number of symbol will be how much? 4 times, yes. So that's why dot dot is given. That's why dot dot is given, that depending upon numerology, number of symbols can be accommodated. On to the frequency side, it is just how much channel bandwidth you have. How much channel bandwidth you have. So that is called. Then every box suppose every box is one subcarrier in frequency domain and one symbol in time domain. Every box is one subcarrier in frequency domain and one symbol in time domain. And this is called the resource element. Every box is one RE, one resource element. Every box is, and you can actually address. So for example, this resource element, the blue color, is KL. KL is like which subcarrier, subcarrier 0 to whatever we have, and L is which symbol, 0 to whatever number we have. So I have tried to make an example for you. This is an example of 5 megahertz channel bandwidth. With 5 megahertz, and I have used 15 kilohertz subcarrier spacing. So if you recall, we can have 300 subcarriers and 25 RB in the table also we saw. So how to make a resource grid of this? So in 1 millisecond, I'll have 14 symbols. So this is my time domain. So symbol 0, 1, 2, I have up to 14 I have plotted. Frequency domain, I have 25, 300 carriers, subcarriers from subcarrier 0, 1 up to 299. So this is a resource grid where I have a 1 millisecond, 14 symbol and 300 subcarriers. This is a resource grid example. This I plotted in a Excel sheet and took a picture here. Then suppose you have 10 mega and using 30 kilohertz subcarrier space. So if you divide this, you'll get 288 subcarriers. That means 24 RB. So that means your subcarriers are from 0, 1, 2 up to 288 and 287. But since you are using 30 kilohertz, your slot size will be 0.5 millisecond. So you'll have a 2 slots in 1 millisecond. That means you can accommodate 28 symbols. So my symbol 0, 1, 2 up to 27. So my resource grid will look like that. So that way you can draw. So you can refer to this particular document which is there, 38.211 about this. Okay, so now question for you, all of you. Resource grid size in time domain is 1 millisecond, 10 millisecond, 0.5 millisecond, or 0.25 millisecond. What is the
1
resource grid
millisecond.
size? Yes,
A.
Venkat is right. Atul sir is right. Okay, great. Uma is right. Suhasini is right. Vikas is right. Loknath ji is right. Okay, good. Okay, the last topic of today. So as I discussed and told you that it is a slot-based scheduling. So if you are using 15 kilohertz, your slot duration is 1 millisecond. For Numerology 1, it is half a millisecond. So it's written in microsecond. Okay. So what happens that every slot you can symbol you have. You can either allocate for downlink or allocate for uplink. So if you have a downlink heavy
Sir, can you
transmission,
please repeat
you
again?
allocate.
Sir, please repeat again, sir.
Okay, so what is slot-based scheduling? So every slot duration, you allocate resources to the users, right? Suppose a user want to use data, then you wait for the start of a slot and allocate. So if I have 15 kilohertz subcarrier spacing, that means every millisecond I'll be allocating resources in frequency and time domain to the user equipment, right? If I have 30 kilohertz, then every half millisecond I'll be doing that. Okay. So suppose whatever my slot duration, I'm allocating it. Then how to allocate for downlink and uplink? So it is very flexible, depending upon, suppose if it is heavy downlink transmission you have, then all the symbols in a slot you can allocate for downlink traffic, and very few for uplink. Similarly, if your transmission is uplink heavy, then you can allocate symbols in a slot for uplink and very less in the downlink. If it is, this is very important. Just see this. Can some of you try to answer what is LBT? LBT? Anyone? If you have heard about LBT, can somebody write in the chat box? The LBT is nothing but listen before transmit. So basically, your Wi-Fi works on that concept. Since Wi-Fi is an unlicensed band, multiple users are connected. So the system they have developed to avoid collision, listen before you transmit. Since 5G will also be operating in unlicensed band, same concept is deployed in the 5G also, and that's why they allow delayed kind of a start. Instead of starting from here, they are listening to the environment, and when there is no downlink or no use, if this downlink transmission is on. So this is called a LBT. So relaxed base station synchronization requirement or that way can be used. Now there is a concept of mini slot, which I'll talk about in next slide. Now suppose there are heavy downlink transmissions, even you can aggregate number of slots. So maybe at start of one slot, you can allocate two slots together so that next slot there is no allotment required, and you can allocate for say completely downlink or completely uplink. So you can aggregate even more than one slot. So this is the concept of slot based schedule. Now there is something called mini slot based schedule. As I was telling, that suppose I am using 1 millisecond subframe. So every 1 millisecond resources can be allocated. But in case of a URLLC, ultra reliable low latency communication, there is a concept of mini slot based. That means in an ongoing time slot, suppose this time slot has started and some data comes. So you can puncture this and give the data into the ongoing slot itself. It's very complex to implement, but this is in 5G. Case your application which you are trying to deploy is of URLLC type, you have an option to deploy mini slot based scheduling. That means here we have up to 1/16th of millisecond of slot duration. And on top of this, you can also break, you can go even lesser in between, you can puncture and give it to your LLC application. So there are certain things that how you can do it, that mini slot, either you can have 2 symbols, 4 symbols, or 7 symbols, and these are the minimum CPV. So Sumit said, I think NR only, yes. So scheduling is done in the base station. So base station is your master. There is a question like Aurelia says. So everything is done. And of course, UV has to match. So it is between UV and G node. So with this, the summary is that low latency application uses this kind of mini slot base. And this is also used in a dynamic spectrum sharing environment. So with this,